Okay. Alright, guys. Now I'm going to the whiteboard. Alright, you'll see on the top of your handout, okay, the IQ normal curve, which I lifted off the internet. And my advice and recommendation is for you guys in terms of statistics. There's no easy way to do it. And for those who aren't here, I will upload the handout onto Moodle so you can see it as well. Okay? There's no easy way to do it. You just need to memorize this curve. It's not that difficult, but it's going to... Oh, sorry. I'm just being stared at by the other assessment tutor through the window. Okay. Stalker. Checking up on my performance. You should be teaching the stats section. But yeah, so because it can provide you with a lot of information, okay? Like when we were talking about what those stats questions look like, okay? By memorizing this curve, you can extrapolate and remind yourself of a lot of information. And it will help you understand like the IQ things too more conceptually, okay? Sorry. And I'm just going to recreate what's on your handout, so if you can't really see it, it's not a big deal. But who remembers what the mean IQ is according to the Weiss and Whisk? 100. Did you read that off your handout, Tarek, or did you just remember? Memorize. That's good. And what's the standard deviation? Okay. So it's going to be really helpful when we start to look at, or when you start to learn, particularly in the intellectual assessment capacity, and looking at mental retardation and how to assess for it, that you understand that this is where it falls on that curve, okay? So you've all done stats, you all know how the normal curve works, right? I'm going to assume we're all at this end because we're becoming doctors, and that's just where we go, right? But you can extrapolate a lot of information based on memorizing what percentage of the population falls in each quadrant of the curve. Does anyone remember that? Did anyone here have Tory for stats? He was gone by the time you guys got here, right? Okay. I remember sitting in my statistics class in first year, and our professor said, you should just memorize what percentage of the population falls in these different sections. And I'm like that's ever going to happen.
Is Tory the professor that everyone is saying, you're lucky this professor isn't here anymore?
Yes, that's the... Oh, question. Is Tory the professor that everyone says, are you glad they aren't here anymore? Yes. If only because of his midterm. But basically what you wanted, there's like, and you can all figure out like semantic and different ways to memorize or short routes to memorize it. But basically 50% of the population are going to be represented on the graph by the time you meet this midline. Okay? So as you can see on your handout, it's, well, they give cumulative, so I'll do it based on mine. 34.13%. 34.13%. Okay? Cumulatively, 68.26% of the population fall within 85 and 150. Okay? These numbers aren't on your handout, but they're basic addition, but if you want to write them in, that's okay too. 13.59%, 13.59%, 2.14, 2.14, and then down here, 0.1. Now, this is important because you might get a question that says, what percentage of the population have an IQ that falls between, or like that is over 2 standard deviations from the mean. Okay? I don't know a way to answer that question without just having to memorize this. And it's not that bad, you find little techniques, okay? So what's 2 standard deviations from the mean? 130? So what percentage of the population have an IQ equal to or exceeding 130? 2.27, right? That will be an answer. It'll probably, like, I think actually that was an answer. Manny's looking at me with that, he doesn't remember, but there might be a question like that, and the only way to be able to answer the percentage of people that fall within certain ranges of intelligence is just to memorize it. Okay? I don't have a shortcut other than just, this is really important. It's also important because when we look at why we use standardized scores, this is also the distribution of all of the subtests for the WISC and WACE. Okay? Who remembers what the mean for subtests are? 10. And what's the standard deviation? 3. 19. 7. 4. 1. Okay. What if you got a question that said, what percentage of people score more than a 13 on similarity subtests? Sorry, Greg? I didn't hear you, sorry, I'm a bit deaf.
Approximately 16%.
Yeah, right? 13.59% plus 2.14% plus 0.13%. Okay? That's why it's so important. Once you memorize this and you understand t-scores, and you can plot a t-score on this distribution, and you can plot subtest scores and mean scores, do you see how you can use it to answer so many questions? Okay, in terms of distribution of scores, but there's no way other than to just memorize it. Okay, so 0.13%, more than 2 standard deviations. 2.14, 13.59, 34.13, and then symmetrical. Okay, guys, does that make sense? And everyone thinks it's pretty straightforward in how to use that graph to answer questions in terms of the distribution of scores? Nods? Yeah? Okay. So all you need to remember to be able to answer any kind of distribution question is these numbers, and then the mean and standard deviation of subtests and intelligence scores. Right? Wrong? It's really important.
Zoe, would you mention like the t-test variations? You know, like on different intelligence tests, they also use the t-scores in some of them. Would you need to know that as well? Or
What you would know, and what I would really recommend knowing, is the slight difference between the Stanford-Binet and the Wechsler, which is also on that image that I gave you. Because the Stanford-Binet has a mean of 100, but its standard deviation is 16. But with t-tests, or t-scores, yeah?
Could you please repeat the question? I didn't hear it.
Oh, thanks, Paul. I don't remember the question. Sorry, guys. It's a lot for me to kind of be putting out too. The question was...
what percentage of scores? That's all I have. No, I was
Figure out
asking
part of
about like the
t-scores.
t-tests.
Oh, so Jessica was asking about the t-test, and I'm going to show how to plot that on the graph now. Okay. Thank you, Paul. Okay, so with t-scores, who remembers what the mean... 50. Let's just put it here, 50. And what's the standard deviation? 10, right? 60. Oh, do it in a different color. Oh. Okay. So again, all you need to remember is what the mean of a t-score is and the standard deviation. Slightly different, right? These ones are fairly ingrained. I think that you get it drilled into enough about IQ that you should be able to remember that. The subtest ones, again, when you're using WISC and you're going to be reviewing it a lot for your other sections, you'll be able to remember that. The t-score, mean of 50, standard deviation of 10. And because it's plotted on the normal curve, it's the exact same thing, okay? It's the exact same percentages. So you can use this curve to understand and be able to answer questions about distributions for any test if they say, it's on a normal curve. One of them might say, a question might say, scores for the TONY, like the test of nonverbal intelligence, are distributed on a normal curve. Someone scores a t-score of 70. What percentile rank are they? Instead of going, holy crap, how do I answer that question? I recommend what I did when I got into my assessment exam right away, because you get scratch paper too. I just had it like memorized rote. I just drew this curve. I drew the curve because I'm a visual learner, that's just me. But I drew the curve and I wrote in these numbers. And I wrote the t-score distribution, IQ distribution, and subtest distribution. And so I had it there. And I did refer to it for some questions in the test. But I just got it out of my system, I drew it on my scratch paper, and it was there because you can use it to answer a lot of different questions. Does that make sense to everyone? Yeah? Okay. The other really important thing, which I think is kind of... So we already ascertained you don't want me to... I'll upload the things, but I don't need to review the different kinds of... Okay, yeah, Tarek says no. That's good. The other really important concepts that I want you to understand are sensitivity and specificity. Who's heard of those? No one? All right. Sensitivity and specificity.
So, if you're going to use a marker, do you mind using a brown one?
Oh, because it shows up?
Yeah.
Okay. I need a different...
I'll go both wrong.
Thank you, Annie. Okay. Everyone remembers type 1 and type 2 errors. Okay? I always used to get them confused. Can someone remind me what they are? I always got them mixed up. What's a type 1 error?
You can know when it's when you should accept it.
Okay. So, positive, negative, positive, negative. So what were you saying, Tarek? That you accept...
You reject the null when you should have accepted it. It's type 1.
Okay. So what square would I draw that into?
I don't know what those mean.
Okay. So this is when I think it's positive and it actually is positive. This is when I think it's positive but it's actually negative.
Okay, so it should go in the minus 1, 2 second quadrant.
This one?
No, up, no, yeah.
So this is type 1.
That's what the minus and the plus means, reject and accept.
Yeah.
Yeah.
Okay. When I think that it's positive and it is positive, I use layman's terms because I get really confused by null and whatever. so bear with me guys, we don't have a problem, right? When I think that it's negative and it actually is negative, we don't have a problem. When I think that it's positive and it's actually negative, what kind of a problem do I have? What? Type 2. Okay? This is how I used to have to remember it because I just got really confused because that's why I did a PsyD. I didn't want to do stats and research. I was a stereotype, okay? But so we have to remember, you're going to be asked about type 1 and type 2 errors. You have to figure out what makes most sense and how you partition those out. It was something that I really struggled and got confused about, so this was the easiest way for me to remember. Okay?
And this is the sensitivity and specificity? Or
Sensitivity and specificity relate to this. Okay? Did you find out? That work? Not as much, but thank you, Mitch. Okay. So sensitivity, and I have my little flashcard here, because this is probably the only time you will have to learn about these concepts, is the proportion of actual positives you get, okay, that you can correctly identify. So sensitivity goes in this box.
So
Okay.
can you repeat that one more time?
So sensitivity is the proportion, is the test ability to accurately identify a positive when it's positive. Does that make sense? Oh. Thank you.
Could you give an example?
Okay, so an example. Sorry, these are really hard concepts and it took me a while to get this, so we might have to revisit it, or Mauricio might be able to explain it better. Okay, so I have an example. Who watches Battlestar Galactica? Okay, eventually. I'm going to go out on a nerd limb. So bear with me, okay? I've developed a test that will help me detect who is an alien machine and who is human. The sensitivity of my test refers to the degree of sensitivity refers to how much my test actually detects when there is an alien machine. Does that make sense? Greg is laughing at me and thinking I'm a nerd, but that's the best example I can come up with after a few hours up here. Does that make sense?
So it's basically how much the test actually tests what it's looking for?
Yes, the degree to which the test actually provides positive results when a true positive is appropriate. Does that make sense to everyone? Okay, sorry, I just feel like the more I say it, the more I'm going to confuse you guys. I'll try to be clear. Okay. Sensitivity is the degree of sensitivity is how often my test says, yes, that's positive when it's actually positive. Okay? So it refers to this column. The more sensitivity I have, meaning the more my test can identify true positives, the less type 2 error I have. Meaning the more true positives I get, the less false negatives I get. Does that make sense? Did I leap too far, or did everyone follow that?
Is that like power?
Power? Yeah. Sure, that's like power. Statistical power. I teach really basic, streamlined, messy stats, so I try to use as fewer concepts when talking about a new concept, but yes. Okay? So maybe I should have written this out for you guys. But so one more time. The sensitivity refers to my test's ability to identify positives when positives are actually present. Okay? So it's the sensitivity of my test is my ability to detect all of the alien machines that are there. And I want to detect as many of them as possible because they're trying to destroy the human race. Okay? Battlestar Galactica. Right?
Can we have a Star Wars metaphors?
Oh, okay.
That's-
Oh, I'm not so good with Star Wars. Okay. This is my Jedi Detector test because I am part of the Sith ring, Darth Sith. Yeah.
I'm following you.
Because I'm Darth Vader and I want to wipe out all the Jedis because they irritate me. And so I developed a little radar measure that is going to pinpoint them all. The sensitivity is my ability to detect the Jedis when they're actually Jedis. Because they're going to face a gruesome death by the Rancors.
I think Darth Vader would care about
Can I do a shout out for Yoda?
For Yoda? I
Yeah.
definitely want Yoda. However, my radar, my Jedi detector, sometimes it's going to make some mistakes. Sometimes I'm going to think that I want positives. I'm going to think they're a Jedi. My radar's going to say they're a Jedi, and they're not. They're just some poor sucker that wandered off and got caught in the crossfires. And they're going to get blitzed too. That's type 2 error, when I kill people that I think are Jedis that aren't Jedis. Oh my goodness, guys, I'm sorry for this metaphor. The more sensitivity I have, the more sensitive my test is to actually detecting Jedis, the less people are going to die. The less type 2 errors that are going to occur. Does that make sense? Yes? Oh my god, you're looking at me like I'm pathetic. Does it make sense? I need nods.
Yes.
Yep? Okay. Beautiful. Thanks, Greg. Now, specificity is the second concept, and it refers to this side, okay? So specificity, if sensitivity is the ability to actually detect positively the Jedis that are there, then specificity would be the flip side, which is the ability to detect when there are not Jedis there. It's the ability to detect true negatives, true humans. Okay? So sensitivity is the ability to detect true positives, and specificity is the ability to detect true negatives. Does everyone follow that? Okay? So, the more specificity I have, the more I'm going to be able to detect true negatives, and I won't think, I won't let any Jedis go, right? I won't think that they're a human when they're actually a Jedi. Does that make sense? No? You guys look confused.
So the more specificity, the more you're able to identify true negatives, and you won't allow yourself to have type 1 errors.
Yes. Sounds so simple when you don't add in a convoluted Star Wars metaphor to make sense of it, right? But yeah, basically that's it. Sensitivity and specificity. These are really important concepts, okay, that for some reason we aren't really exposed to, but you're expected to know in terms of the comprehensive exam. Okay? So, one more time. What does sensitivity of a test mean? Yes. What does specificity mean? Exactly. Oh, sorry. Sensitivity is the ability to identify true positives, and specificity is the ability to identify true negatives. Do you want to know how I remembered that? I was like, oh, it would make perfect sense if specificity, being that it has a P in it, was about true positives. And because nothing about this exam makes sense, I just went, it's the opposite, okay? That's how I made sense of it. That's why you don't cram in the last 3 weeks, because you rely on horrible little clues for yourself like that. Let that be a lesson to you guys, okay? So, specificity, one more time, is the ability of a test to identify true negatives the more specificity we have, the less type 1 errors we make. The more sensitivity we have, the more we are able to detect true positives, the less type 2 errors we make. Does everyone get that? Or the beginnings of it? You might have to just say it to yourself a few times. I draw the square thing like that. Figure out a way for it to make sense. That's definitely not the best way to do it, but that's just how I learned it. Yeah, Jessica.
So for specificity, not only does it detect true negatives, can you also say it detects less false positives? Or is that only for sensitivity that you can kind of do those lines?
Hold on. So for specificity, yes. So with specificity, you can say that you can detect less false positives. Okay? With sensitivity, you can also say that you will detect less false negatives. Does that make sense to everyone? However, there are costs with everything in statistics. Okay? So the more specificity I have, the more I increase my ability to detect true negatives. Okay? I'm also going to get some more false negatives. I won't get as many false positives, but I'll get some more false negatives, okay? Because I'm making it so geared on detecting negatives. With sensitivity, alright, I'm going to be able to detect more true positives. I'm really oriented and focused on being able to detect true positives, but a cost or a byproduct of that is that I'm probably going to get a few more false positives. Does that make sense? Everyone? So you need sensitivity and specificity, okay? Everyone looks a bit, yeah? They're really important things. The curve and sensitivity and specificity are really important, okay? That's why I have little flashcards about them. And like, look, I even need to refer back to my flashcards to make sense of them, because you learn them for the sake of the test and then you don't really need to use them again. But so does that kind of, does everyone hold that well? Okay. Well, so it's 3:30. All right, and so we can stop there. But if you can quickly look at your handouts that I've shown you, so I can just quickly go over at least what's in them and what you need to look at. Okay. I've gone through reliability theory. Okay. Now, when you have your thing with Dr. Chang, when you have it with Dr. Chang, he's going to go over classical test theory in a lot more detail. But this is like a more streamlined, like I just extrapolated what I thought were the most important parts of that. This should not be the beginning and end of your study guide for the stats section, okay? Because it's just what I developed from my materials, but it doesn't represent the best. I encourage you guys to all expand on it. But I've gone through, I look at like reliability theory, okay? Classical test theory, which is like the true score and the nature of error, okay? Where a true score equals your observed score plus error. Okay, I have that in there. That's really important. I'd really encourage you guys to kind of like know that well. That is when you, can you see the thing that said standard error of measurement, SEM? And it looks at sources of error, and then it goes through and, oh, actually I don't have the, okay, give me 5 minutes then. Look at the standard error of measurement section, and I'll just go over this really quickly with you, okay? And then I'll let you guys have a,
Use the other whiteboard.
oh yeah, thanks.
You don't want to draw on the smartboard?
What?
Do you want to use the smartboard?
I was going to try, but that's okay. Okay. Can everyone see this one okay, even though We're at the angle? Okay. Classical test theory. Alright? Remember when I was talking before about IQ? And the idea that when I say I have an IQ of 147, that's not my true score, that my true score exists within a range. Well, that's not even, there's another element to that, okay? True score is a theoretical concept. We want to get as close to our true score, meaning our true score is an exact representation of our abilities in any given test. Let's use intelligence because that's a nice solid example, okay? Now, my true score, and we'll represent it as, okay? My true score is equal to my observed score the score that the test gives me, in this case 157, right? Plus error. Error. Okay? Error has many sources, which I list on your handout. There is human error, because the administrator might make mistakes, even though it is a standardized test. Well, wait, why do we use standardized tests? To reduce error, right? You just said it. We use standardized tests to reduce the amount of administrator variation, which is error. Human error. Administrator error. I make a mistake. I don't use the discontinue rule when I'm meant to. Or I start you on a different point. Or I don't stop my stopwatch perfectly when you finish the block. Or I make a small calculation error, okay? All these things are error. The time of day. If I do my test really early in the morning and my participant comes in and they didn't have their coffee, or they had a nightmare last night and they didn't sleep well, that's error. So many sources, right? Infinite numbers of sources. As psychologists, we want to reduce error as much as we can. That's why we use standardized tests. That's why we do mental status exams. That's why we give our test takers breaks, right? Do you need a break? Yeah, I think I do. Okay, go and have a juice, whatever. It's all about reducing the possibility of error. Now, this can never be zero, unfortunately. We are not robots. It is not a perfect world. There will always be some error, but we can control it to a certain point, okay? And that's what we try to do as clinicians. We try to minimize it, but it will never go away. Because we will never be able to completely remove it, this will always remain a theoretical concept. Does that make sense? So that's what classical test theory posits, okay? That our observed score that we write about is the best estimate we have of ability. It is not the true score. Does that make sense to everyone?
You say best estimate of ability?
Yes. It's the working estimate of ability that we have. It's really good. It's not going to be completely inappropriately wrong, as long as we are conscious of error. Does that make sense to everyone? So that's classical test theory. We want to reduce the amount of error, and the more we reduce the amount of error, the closer we get to the person's true score. Okay? In the handout, we talk about different sources of error. Okay? I apologize that this equation wasn't on it. Dr. Chan will also go over this a lot. Dr. Chan, why don't you say Dr. Chan? Dr. Chang will go over this in a lot more detail as well. But that's the basic posit of it, okay? Does that make sense to everyone? So they're really important things to know. Assessing reliability, okay? Now I've included in the handouts like the R coefficient, Cronbach alpha, And they were all they're kind of basic statistical ideas. Don't get freaked out. Statistics was easy to drone out in, but you remember the idea of Cronbach alpha, right? And if you don't, just go back and review them. You don't need to know these statistics in excruciating detail, but you do need to know conceptually what makes a strong test. Okay? Let's see. The different kinds of reliability I go through. Then I look at the sources of error. Okay? I look at the different kinds of validity. Different kinds of bias. Okay? And then characteristics of generalizability. And characteristics of a good test. Okay?
Can you repeat what you just said? You said characteristics of what?
Characteristics of generalizability. Now you'll notice on my handouts that I used that some sections had a lot more information on them than others. Okay? Like validity of individual results and response styles, and clinical judgment and inference. Okay? Clinical versus statistical prediction debate. Right? I only have one line. Statistical prediction trumps clinical prediction because there's no bias. There's no human bias in that. All right? Use your own judgment too in how much detail you think you need to go into something. But some of them, you're not going to need to write pages of notes on each point. That's not how the test is designed. Some points are going to require a lot of in-depth note-taking on your part, and some it's just going to be like, oh yeah, okay, I get that. That's what I mean. These are not the beginning and end of your notes. These are a starting point for you guys. Okay? Does that make sense to everyone? Do we have any last-minute questions, concerns? No? We all feel cool? All right then. Thank you for coming in, guys. Oh. I can hear myself and it's freaking me out.